In this video, you will understand concrete design and learn how to interpret and validate results. I currently have Robot Structural Analysis 2021 running. Let's begin by opening the model concrete frame _ 2021 RTD. In this video, you will learn the basics of concrete design on a concrete strap beam or ground beam. This beam connects two pad foundations, which in turn supports the two steel columns and the steel frame above. Let's begin by modelling the strap beam between the two pad foundations. On the Structure Model toolbar, go ahead and select the bar command. In the bars dialog box, we'll go ahead and select RC beam for our bar type. We will need to create a new section size for our strap beam. Select the New Section button, and in the New Sections dialog box, we'll go ahead and define our new section size. So the label will simply be the reporting name of this beam, and this one here is going to be 18 by 28. We can then set the B field, so that's going to be 18, and obviously the height here will be 28 inches. We will also set the reductions of moments of inertia. This will reduce the moments of inertia for section cracking. Let's set the coefficient of 0.75 to all three of these fields. So I'm just going to paste that in, like so. And then we'll go ahead and click Add. And we can then go ahead and close down the New Sections dialog. In the bars dialog, we're just going to confirm that we in fact have our section 18 by 28, and we can then model in our beam between the two supports. Now this second dialog here is just confirming that our results are now out of date. We can just go ahead here and select yes. Let's go ahead and close down our bars dialog. And just to help us understand what we've modelled, we're going to switch on our section shapes and also display the local coordinate systems for each of our members. We will now add a uniform load to the beam. On the Structure Model toolbar, click Load Definition. In the Load Definition dialog box, select the Bar tab and click Uniform Load. We will now add a dead load of -3 kips in the Z direction. This load will be factored up by 1.2, which will give us an ultimate load just over 3.5 kips. Click the Add button and then go ahead and select the concrete beam and then click Close. The load has now been applied. Next, we run the calculations. On the standard toolbar, click on the Calculations button. And the calculations have now run. We will now take a look at the results. On the standard toolbar, select the Layout drop-down, and from the Layout drop-down, select Results, and then Results again. In the Diagrams dialog box, ensure that you have the NTM tab selected, and then enable the moments, and click Apply. In order to see the moments better, we will now switch off these section shapes. From the results, you can see that we have a simply supported beam. When we inspect the start and end of the beam, we can see that we have some fixity. This is due to the interplay with the moments. To simplify the results on the beam, we will go back to the start layout and change the release conditions of our beam. On the standard toolbar, select the Layouts pull down, then select Structural Model, and then pick Start. Select the concrete beam, and then in the Object Inspector, you'll notice here we have releases. We're going to set the releases here to pinned. Again, this dialog box is informing us that the results have now changed, so we'll just go ahead and say yes there. And before we rerun the calculations, what I'd like to do is remove the self-weight from the beam. This is really to simplify the verification of the hand calculations that we'll look at later on in the video. To do this, on the standard toolbar in the Layouts pull down, we'll go ahead and select Loads. In the lower half of the dialog, you'll see that we have our load cases table. And notice here that we have two dead load ones. This dead load one here was the one that we added to our concrete beam, but this one here is the self weight of the structure. This is the one we're going to delete. So we'll select the row and then press delete on the keyboard. Of course, we will now need to rerun the calculations to update the results. So once again, on the standard toolbar, let's select the calculations command. And the calculations then rerun. To now review the results in more detail, we'll go again to the standard toolbar, and in the layouts pull down, we'll go ahead and select results and results again. Of course, we can now see that we are reviewing the results for dead load 1. We've got a very simple moment diagram with no interplay from the fixed conditions on the columns. If we take a look at our maximum value here, we can see that we have 337.5. To verify this, we'll now run through some hand calculations. We'll begin by using the built-in calculator within Robot. On the Home ribbon, let's go ahead and select the Tools command. In the Tools toolbar, we'll select Calculator. And to perform the calculation, we will take the span, which is 30 feet, and we will then square that, which gives us 900. And we can then multiply this by the load. So of course our load was 3 kip, so we'll say multiplied by 3, and that gives us 2,700. And then if we divide that by 8, you'll then see here that this gives us the simple design moment. You'll notice that this correlates with what we've got down here, so 337.5. So once again, we can see with simple hand calculations that we can verify and understand the results that Robot has given us. This concludes the video.